begin by measuring 10 milliliters each of the sodium hydroxide and the crystal violet. Pour each of these into separate small beakers. Then place the beakers into an ice bath. This way they will be very cold when it is time to do our second trial at a lower temperature. You can use a large beaker or share a crystallization dish with another lab partner. After you have set this up, again measure 10 milliliters of each chemical to be used with the room temperature reaction.
These colorimeters that we will use are a little bit different from the ones in the video, but the setup is very similar. So you're first going to need to calibrate it. Now, something I want you to notice is that if you look inside, you should be able to see the color of the light that is coming through. And as you change the color on the wavelength, we should see a different color of light. Okay, we're going to set it to the 565. These cuvettes are a little different than the cuvettes we've used in other labs. You'll notice first they are square. There's a side that has ribbing on it and a side that is smooth. We want to avoid touching the smooth side because this is the side that light will pass through. Your lab manual refers to a reference mark. Sometimes you will see at the top of one of the edges a triangle. If not, just make sure that you face one of the clear sides towards the reference mark. We're going to put in distilled or deionized water for our calibration. You're going to hold the cal button, and below there will be a red light, and you're going to wait for that to stop blinking, so it'll take several seconds. And this will tell the colorimeter how much the water by itself is absorbing, so we're not having that get in the way of our measurement. You can then remove the water and proceed with your directions. When you open Graphical Analysis, you should see a screen like this that asks you how you want to collect your data. We're going to use Sensor Data Collection. So you're going to tap on that. You need to make sure that the colorimeter you're using is turned on. So there's a power button right here, and the light should be blinking. And right above the blinking light, there is a number. You're going to match that ID number to what is on your screen. So in my case, it's this first one. I'm going to connect it. It should appear at the top here, and then I say done. Once I have done that, I'm going to need to set up the mode according to the directions. So you want to set your settings so that it is time-based. We're going to do this in minutes. So change it to minutes, otherwise you'll have to calculate how many seconds this is. 2 samples per minute is fine, that's every 30 seconds. Or if you want to make it more, that's fine as well. I'm just going to try it at 4 samples per second. If we get this NaN, that means that it's done something wrong, and so you're going to need to make sure that that's not superscripted. So I'm going to delete this. And I also need to delete the bottom part. Oops. And try this again. Okay, so now it has the 4 samples per minute, and it's automatically calculated what the interval is. The other thing I want to change is amount of time. So our lab says to do this for 20 minutes, so we want to make sure that we set it to 20 minutes. And again, I've got this superscript. I don't know why it does that sometimes, but if it superscripts, it doesn't like it. So we're going to try it again. Oops, got a superscript. But once you get it not to superscript, then you hit done.
Once you mix your reactants together, you want to swirl them around, make sure they react for a few seconds. And then you can transfer some of your mixture into the cuvette. Remember that if the cuvette is wet, you're going to want to rinse it first. So you're going to put a small amount of your liquid in, fill it, dump it out, and then we're going to do that again. This is called fill, dump, fill, dump, fill. And so the third fill we will keep. Now we want to keep our cuvette from getting warm by what's going on inside the colorimeter. So what we're going to have to do is take it out after each reading. So we can stick it in, and then we can start the collection. And we'll wait for that first data point to appear. And one thing that you can do is you can show the data table. And so you'll see when that first data point appears. When it appears, you're going to take out your cuvette and just let it out for a few seconds. And then you'll stick it back in so that it's there for the next reading. Now the first one, you probably don't want to put it out too long, but I just got one more data point. So now I have 30 seconds. So I'm just going to count to 10 really slowly. 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to put it back in so that it's ready for the next reading. And then I'm going to watch the graph. And as soon as that graph goes over, I'm going to pull it out again so it doesn't get too warm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to open it back up again and stick my cuvette back in. And I'll continue this procedure for 20 minutes. Before you get started on your data collection, make sure to take the temperature of your mixture so that we have a comparison for the colder temperature data. You're going to want to leave that in there at least 20 seconds so that it can calibrate and get to the right temperature. It should be pretty close for the room temperature one. It'll take longer to calibrate for the cold temperature one. Once your data collection is complete, you're going to need to set up your data table so that you can do the analysis. So what we want to do is click this button in the corner that has the rectangle and 2 squares. And we want to see a data table. So I'm going to move the graph out of the way for the moment so we can add our extra columns. Just scooch this over. And we want to do our order test. So we are going to need to look at absorbance versus time. And remember from our Beer's law that the absorbance is proportional to concentration. So we're going to use this as if it were concentration versus time. So that's going to be our 0 order test. And then we are going to need to do our first order test, which is the natural log of concentration versus time. So we're going to need to have the natural log of the absorbance. So we need to set up another column. So we're going to click these 3 dots next to absorbance, and we're going to add, we are going to add a calculated column. So this calculated column is going to be the natural log
of the absorbance. And we're not going to put any units in. And then we are going to insert an expression. So here, we're going to look on here until we find the natural log, which is here. And we don't really care what the multiplying factor is, the coefficient is, so we're just going to leave that as 1. And then we are also going to do this in reference to the absorbance. So if it says anything other than absorbance under column X, that's what we need to do there. So we're going to apply that. And then our second order test is 1 over the concentration. So we're going to do 1 over the absorbance. So again, we're going to add a calculated column. And we are going to change the name of that. So you can call it 1 over absorbance, or you can call it inverse absorbance. All right, so now we are going to look at the graph. Now we're going to look at the graph. We want to see which of these graphs is the most linear. Now this might look a little bit linear to you. It might look a little bit curved. One way we can help to see that by looking at it is by narrowing down our range to on the y-axis to just the area that we're using. So remember, you can go to the edit graph options, and we can decide that instead of doing 0, we're going to do 0.3, and instead of 1, we're going to do 0.6. And that will spread out our data a little bit. It looks like we need a little bit lower than 0.3. So let me make that 0.2. There we go. All right. So then for each of the graphs that we do, we're going to apply a curve fit. So again, click on the little graph in the corner, and this time we're looking for apply curve fit. And so it's applying a linear fit. And so you can see that the points are above the linear line at the beginning and end, and they're below in the middle. And so that's an indication that this is curved. But we can go ahead and apply that. And then we can pay attention to our RMSE, root mean squared value. And this, we can look at our R value here. And so this is going to be negative because the slope is negative, and then we can see it as 0.987-ish. So that's a pretty good correlation for some sciences, but for chemistry, we're going to say it's not good enough, especially since we have this indication that it's probably curved. Okay, so we're going to look at some of the others. So now what we're going to do is, and you can save this as a screenshot so that you can show that graph in your lab report. Now what we're going to do is click on absorbance over here. Now what we're going to do is click on absorbance over here. There we go. And you'll notice that we have some different options. So we can show what's on each axis. And so now I want to see the test for the first order, and that's the natural log. So I'm going to turn off the absorbance and just have the natural log. And so it has auto-scaled for me, so it's showing that section. Notice that my numbers here are negative. This is because I'm taking the natural log of a number that is less than 1. And I'm going to be looking to see where my fit is. And finally, I'm going to change this axis to and record our slope and our R value. Now I'm ready to do my cold temperature reaction. Remember that temperature relates to the reaction rate in that it slows down the molecules, reducing the number of collisions and making the rate slower. My two beakers have been sitting in an ice bath for a long time now as I did my first reaction. I'm going to mix the two together, and I'm going to start the time on my computer by hitting collect. It will ask me if I want to store the latest run or erase and continue. You may want to store the latest run so you can refer to it later. I need to determine the temperature of this reaction. Leave the thermometer in the beaker for several seconds so that you get a good reading. The temperature will continue to drop and remain steady when it is at the appropriate temperature. This seems to be holding steady at 3.2, so I'm going to record that in my lab manual. I'm going to return the beaker to the ice bath so that it can stay cold while I'm waiting for my process to start. I'm going to stir so that all of the reactants are properly mixed. Before 3 minutes have passed, be sure that you fill your cuvette 3/4 full. This had the other concentration of crystal violet in it before, so I'm going to use the fill, dump, fill, dump, fill method. I'm going to fill to collect all the droplets of the crystal violet and dump that out. Do that twice and then fill it to 3/4 full. I want to be sure that the outsides of my cuvette remain clear, so I'm going to take a tissue or a chem wipe to wipe down those smooth sides while trying to hold only the ribbed sides. Then I'm going to replace the lid and keep this cuvette in the ice bath. When you remove the cuvette from the ice bath, it will be wet and may also be somewhat cloudy. Be sure to wipe it off with the chem wipe before you insert it into the calorimeter. It won't be as steady as the last reading as the temperature will be beginning to change.
So just hit the keep button after about a second or two and then proceed on as you did with the room temperature measurements. Take out the cuvette in between so the light from the colorimeter doesn't warm it up.
For best results, once you have started making your measurements, do not put the cuvette back in the water, but keep it near the ice bath so that the temperature does not rapidly change. I've set up my lab notebook ahead of time and recorded the temperature data as well as the slope and the correlation that I have found for my initial room temperature reading. I also need to record the slope and correlation for my cold temperature reading. On the following pages, I will have to write down the evidence that I have that my reaction should be using this slope and not the other slopes. I will also do calculations correlating the rate constant to the activation energy. We will need to have our temperature in Kelvin, so be sure to convert these. Answer the processing the data questions in your lab notebook. The questions are started here, but they are not completed, so don't just copy down what's written in this notebook. You'll need to answer them yourself. Remember that in order to determine the rate constant K, you will be looking at the slope of the graph that is most nearly linear. Rate law in question 3 will take this form, but you will need to indicate the order of the reaction with an exponent here. We didn't collect enough data in order to determine the half-life according to the first part of question 4. You might be able to consider how we would know that just by looking at the data. Nonetheless, you can answer the question about what the half-life is by using the equation. Repeat the collection of the rate law and the rate constant for the cold temperature data and use it to solve for the activation energy. The equation is shown here with the variables defined. Your R value is the gas constant in terms of joules per mole Kelvin. Remember that this is joules and not kilojoules. You will need to follow up by answering the post-lab questions indicated by your professors.